Gustav Robert Kirchhoff was a German physicist who was able to explain the way electric circuits run. Understanding circuits is a critical part of physics. Current and voltage are two important concepts in electrical circuits.
Kirchhoff derived the junction and loop rules, which are now known as the Kirchhoff rules. These explain how current and voltage function in an electrical circuit. Today we will be analyzing these rules and how they work.
In order to truly understand these rules, it is important to know what current and voltage are. Current is an amount of charge per time, while voltage is an amount of energy per charge.
The junction rule explains the role of current in a circuit. At a junction, the total current flowing in must equal the total current flowing out. This is explained by conservation of charge. In this example, there are 13 amps exiting from the top and 7 amps entering from the bottom. Therefore, 6 amps must enter from the left in order to satisfy the junction rule. In this example, there are 13 amps entering and 5 amps exiting the junction, which means that 8 amps must exit the junction on the left in order to satisfy Kirchhoff's junction rule.
The loop rule explains conservation of energy in a circuit. Through a loop in a circuit, the sum of all voltages must be zero. This means that all the voltage gained through the battery in the beginning of the circuit must be lost by resistors throughout.
In this example, 11 volts are gained by the battery, and therefore 11 volts must be lost throughout the circuit. If 3 volts are dissipated through the first resistor, and 2 volts are dissipated through the second resistor, that means 6 volts must be dissipated through the last resistor so that 11 volts are dissipated in total.
In this example, both of the resistors must dissipate 15 volts because they each complete a separate loop. No, you have to go closer like this. Do you see me right now?
No, I see like a quarter of your face. Alright.